Alright, so let's look at these two problems. So here is what the first one says. A garden has 4 rows. There are 12 flowers in each row. Each flower has 2 petals. How many petals are there in all? So I read it one time, so let's read it a second time. A garden has 4 rows. There are 12 flowers in each row. Each flower has 2 petals. How many petals are there in all? So the first thing I have to decide, is this the one-step problem or is the two-step problem? Well, I know there's a garden that has 4 rows and there's 12 flowers in each row, so that's one thing. But then it also tells me that each flower has 2 petals, so this is actually our two-step problem. So I know that I'm going to have 2 strip diagrams. So let's think about the first one. The first strip diagram is going to be a garden with 4 rows and 12 flowers in each row. So my strip diagram is going to look something like this. I have row 1, 2, 3, and 4. There are 12 flowers in each row. I'm trying to figure out how many flowers there are all together. So if I wanted to write my equation, I could say there are 4 groups of 12, or 4 times 12 equals the total number of flowers. My second step is going to be using that number of flowers, and I'm going to say that each flower has 2 petals. So my strip diagram would look something like this. I know that I have some number of flowers. I don't know what that number is yet, but I know each flower has 2 petals. Remember, these dot dot dots means that it keeps going until we're completely at the end. And we're trying to figure out how many petals there are all together. My equation is going to look like this. However many flowers I have times 2, and it's going to tell me how many petals there are all together. So that's my strip diagram and my equation. So now I'm going to move to my estimation. So I'm going to bring my first equation down. 4 times 12 equals how many total number of flowers there are. Well, I know 4 is pretty close to 5. And I know 12 is pretty close to 10. So I'm just going to use those two numbers. So I'm going to say 5 times 10, and I'm just going to skip count. So I could skip count by 5, or I could skip count by 10. I'm going to skip count by 10. 10, 20, 30, 40, 50. So I know there are about 50 flowers. And I have it highlighted because I know I'm going to need it for my second step. So let's move into our second step. So let's bring down our equation first. So some number of flowers times 2 equals the total number of petals. Well, I just figured out how many flowers I have. I have 50 flowers, so I'm going to fill that in. So 50 times 2 equals my total number of petals. Excuse me. Well, I know from counting money that if I have 50 and I have 50, that gives me 100. So I know I have about 100 petals. But now I'm actually going to solve it to see. So I'm going to solve my first step. So I'm going to do 4 times 12 equals my total number of flowers. So I'm bringing down that equation. And I'm actually going to do 4 groups of 12. And I'm going to go ahead and make an array with my actual flowers. So here are my flowers. I have 4 groups, 1, 2, 3, 4, and there are 12 in each. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So from here, I could either count by 4s, I could count by 12s, or I could count every single flower one by one. Whichever one works for you is whatever works for you. I'm going to go ahead and count by 12. So 12, 24, 36, 48. So I have 48 flowers. I'm going to then move to my second step. So I'm going to go ahead and bring my equation down. However many flowers times 2 equals the total number of petals. Well, I just figured out I have 48 flowers, so I'm going to go ahead and fill that in. So 48 times 2 equals my total number of petals. This time I'm going to go ahead and use my partial products method to solve. So I'm going to set it up. I have decomposed 48 into 40 and 8, and then my 2 is over here. Now I'm going to have 2 times 40, and I'm going to have 2 times 8. When I multiply 2 times 40, I get 80. When I have 2 times 8, I get 16. Now remember, I'm going to add my 2 partial products together. So I'm going to add 80 plus 16. But I kind of have a hard time adding 16. So I'm going to decompose it into 80 plus 10 plus 6, because that is easier for me. So I'm going to say 80 plus 10 is 90, and 90 plus 6 more is 96. So I know that my answer is 96. Let's look at our second question. Our second question says that Luis has 32 shirts. Cam has twice as many shirts as Luis. Gavin has 64 shirts. How many shirts does Cam have? Well, just like I did yesterday, I kind of made this one a little tricky on purpose. What information do I not need to know about? I hear lots of good things. Let's read it one more time just to make sure. Luis has 32 shirts. Cam has twice as many shirts as Luis. Gavin has 64 shirts. How many shirts does Cam have? I don't need to know how many shirts Gavin has. My question has nothing to do with Gavin. My question has to do with Cam, but I need to know Luis in order to answer Cam. So I know that Luis has 32 shirts, and I know Cam has twice as many shirts as Luis. So my strip diagram is going to look something like this. Here's Luis, and Cam has twice as many as Luis. So if I actually broke this apart and actually made another one, it would be the same size. So I know that Cam has twice as many, and I'm trying to find the total number of shirts that Cam has. In order to do that, I'm going to use my equation of 2, because twice means times 2. 2 times, or 2 groups of 32, and that's going to give me my total number of shirts. So I'm going to go ahead and do my estimation. So I'm going to bring down my equation just so I remember. And I'm going to go ahead and leave the 2 where it's at, because 2 is pretty easy to work with. I can always just double things. And for 32, let's go ahead and round it like we've been practicing. So I have 30 on this side, and I have 40 on this side. I have 32 right here. Is 32 closer to 30, or is 32 closer to 40? Nice job, guys. 32 is closer to 30. So I'm going to say 32 rounds to 30. Now I need 2 groups of 30. So I'm going to go ahead and use my base 10 blocks to help me with that. So I'm going to make one group of 30, and I'm going to make another group of 30. And whenever I do that, I'm able to count, and I have 10, 20, 30, 40, 50, 60, so I know there are 60 shirts. Now I'm actually going to solve it. So I'm going to go ahead and bring my equation down. So I have 2 groups of 32. It's going to tell me how many shirts I have in total. So again, I'm going to use my partial products to help me. So I'm going to set that up first. I'm going to go ahead and decompose 32 into 10s and 1s. So I have 30 and I have 2. And then I have my 2 over here. So in this box, I'm going to do 2 times 30. And in this box, I'm going to do 2 times 2. And I went ahead and used my base 10 blocks to help me. So I needed 2 groups of 30. So there's a group of 30 and there's a group of 30. And I can count it 10, 20, 30, 40, 50, 60. So there's where my partial product of 60 comes from. And then 2 times 2, if I forgot, I have my 2 groups of 2. So I have 1, 2, 3, 4. So there's where that comes from. Now remember, I'm going to add my partial product. So I'm going to add 60 plus 4. And when I add 60 plus 4, I get 64 shirts. Now remember, the last thing that we do is we actually compare our answer to our estimate to make sure it was reasonable. My actual answer was 64, and I said that my estimate was 60. 60 and 64 are pretty close together, so I know that my answer is reasonable.